Okay, so we're going to be having a look at a particular parabola today when we're revising quadratics. And this parabola has equation x minus 1 squared plus px. X minus 1 squared plus px, where p can vary. So I've made a slider here on Desmos, which I can slide up and down between minus 10 and 10 here. I can slide it across, and that'll make that parabola change according to the value of p in x minus 1 squared plus px. So if I do that, if I grab this slider and slide it along, you can see the parabola moving. The more negative I get toward it, just goes down. Whoop. And as it gets positive, up it comes. See, p is 0 there. Then p goes up to about 2-ish, and it's on the axis. Then p is 4 there, and now p is 5, 6, 7, 8, and it goes down there. So as you change the value of p, this parabola moves around the number plane. But can you see that the parabola's vertex is moving in a parabola? The vertex of the red parabola, as it moves in a parabola. And we can find its equation. And that's going to be part of what we're looking at today. So I'll come back to that with our final answer, and I'll see whether we get the correct answer that describes how the vertex of this red parabola is moving as I move the value of p around. So let's have a look now at what the actual question is that we're trying to answer, and we'll take it from there. So the question that I want to get an answer to starts off here with this expression. So I'll just turn this power off over here, and we can get started. So consider the expression x minus 1 squared plus px, which is what I just showed you a picture of. X minus 1 squared plus px. It's saying find the values of p for which x minus 1 squared plus px is even. What values of p makes this an even function? Well, what does being an even function mean? It means that if you put minus x in, you get the same as if you have x in there. F of minus x equals f of x. So we're saying that if you put a minus x in there and a minus x in there, it should be the same as just if you have x's in those two positions. F of minus x is the same as f of x. So I should be able to solve that out for a value or values of p that make that happen, unless it's never an even function. But it's a parabola, so as long as we can get it sitting on the axis, the y-axis, it's going to be even. But if it's anywhere over to the side, well, it's not. So let's expand this out. X squared, and then that'll be 2 times plus 2x minus 1, plus 1, minus px equals x squared minus 2x plus 1 plus px. So if we get all the px's over there, x squareds will cancel, 1's will cancel. We've got 2x here and a minus 2x there, so that's 4x on this side, and px plus px, that's 2 px's. Now I'll factorise that, so I get 2px minus 4x equals 0. And if I just move this down a bit, you can see that 2x P minus 2 equals 0. So P equals 2. X equals 0 also makes it trivially an even function, but P equals 2 will make it an even function. We might look at it again when we checked out that picture that I had from Desmos. But let's just have a look at another question which we can also get from this situation. Find the values of P for which the equation has no real solutions. Well, there's a few ways to do this, because we know with parabolas, if they've got no real solutions, then in the quadratic formula, the part that's under the square root sign, you want that to be negative, because you can't square root a negative and get a real number answer. So, you know, the discriminant, b squared minus 4ac, if that's negative, we'll have no real solutions. So we could actually find the discriminant of that and see where it is negative. That's one way to do it. We could also look at the vertex. We could find what the y value of the vertex is in terms of p, and as long as that's sitting up above the x-axis, then it's going to have no real solutions, and that is because it's a happy parabola. If it was a sad parabola, I'd want to have it down below. So I might try those two different methods and see what I come up with. The first method is to make the discriminant of this be less than 0, and I think that's probably our best bet. So I might just expand this out and make it x squared minus 2x plus 1 plus px equals 0. So it's x squared plus p minus 2x plus 1 equals 0. So I've just written it in a form where I can see the a, b and c in the discriminant, so I can work that out. So the discriminant for this, b squared minus 4ac, is p minus 2 squared minus 4 times a times c. And I'm going to want that to be less than 0. I'm going to want that discriminant to be less than 0. So this is p minus 2 squared minus 2 squared is less than 0. Give myself some more room here. So that's the difference of two squares, p minus 2 minus 2 and p minus 2 plus 2 is less than 0. So that's p minus 4 times p is less than 0. Now the way that we've been solving those is to draw up a little picture. That's where it equals 0 and where it equals 4. It's a happy parabola. And we've been asked, where is it less than 0? Well, between 0 and 4. P is somewhere between 0 and 4. So there's an answer to that question. Find values of P for which the equation has no real solutions. I'm saying between 0 and 4. That means the parabola will be up above the axis between 0 and 4. It can't cross it, or it's got solutions to the parabola equaling 0. Now, there is another way we could have done that. And I'm interested in it because my last question is focusing on the vertex. So I'm interested in having a look at this parabola here. So we've got y equals this, and I'm interested in, we've got this parabola here, and I'm interested in finding the vertex such that the parabola is above the x-axis, because it's a happy parabola. So if it's above the x-axis, it's got no real solutions. So I'm just going to rewrite it as before, as x squared plus p minus 2x plus 1. And then I'm going to find the coordinates of the vertex. Now that's not too hard because the x-coordinate of the vertex, the axis of symmetry of any parabola, is minus b on 2a. So minus b on 2a is minus on 2 times 1, right? So it's just minus p minus 2 on 2. Or you could write 2 minus p on 2 if you want. But that's what it is, right? So that there is the x-coordinate of the vertex, right? Or if you like, x equals that is the equation of the axis of symmetry of that parabola. It varies depending on what p is, of course. Now, if I take that x-coordinate and put it back into my equation to find the y value, I need the y value to be positive, up above the x-axis. So I've got no real solutions. So I'm going to put it back in here, right? Minus of p minus 2 on 2 squared plus p minus 2 times minus of p minus 2 on 2 plus 1. That's what y equals. That's the value of y when I substitute this in here for x in that equation. And I want that value of y to be bigger than 0 because I want the parabola to be up above the x-axis. All right, so this is p minus 2 squared on 4. And this is minus p minus 2 squared on 2 plus 1 is bigger than 0. So multiply everything by 4. P minus 2 squared minus 2p minus 2 squared plus 4 is bigger than 0. Get another pen maybe that works. All right, that's minus of a p minus 2 squared plus 4 is bigger than 0. So that's a squared minus b squared is bigger than 0. So a minus b, a plus b, 2 plus 2, that's 4. So 4 minus p times p is bigger than 0. This is a sad parabola. Sorry, I just need to give you to be able to see that. This is a sad parabola because it'll be minus of p squared. So we've got a sad parabola going through 0 and 4. We want to know where it's bigger than 0. Once again, if I draw up a quick picture, zero, 4, sad parabola. Where is this sad parabola bigger than 0? In between. So P is in between 0 and 4, which is the answer we got before when we did that other way. So that's the values of P for which that equation has no real solution. Now, the last part of the question, we wanted to know, and this is an extension question because it involves parametrics, but we want to know the equation of the parabola that describes the location of the vertex of this as P varies. So our parabola moves around the number plane as we change that value of P, but it moves around in a certain way such that its vertex follows a different parabola. What parabola is that? That's what we want to find. So how are we going to go about that? Well, since I've done some work over here on the vertex, I'm going to bring those values over here and say, since we're focusing on the vertex, since we're focusing on it, what are its actual coordinates? Well, the coordinates of the vertex you've got your x equaling minus b on 2a, which turns out to be minus p minus 2 on 2, when that was expanded, right? Because this thing's equation from before is x squared plus p minus 2x plus 1. So you can see that it's minus p minus 2 on 2, minus b on 2a. And when I substituted that minus p minus 2 on 2 into the equation, I got y is equal to minus p minus 2 squared, that thing there squared, plus p minus 2 times that thing, plus 1. So that's the y value of the vertex. That's the x value of the vertex, that's the y value. We can tidy this up, but can you see, let's just tidy this up here. Instead of p minus 2 times minus p minus 2 on 2, that can be just p minus 2 squared, minus of p minus 2 squared. So I'll just pop that in there. Minus of p minus 2 squared on 2. Okay. So if this is the case, x is equal to this. So I can replace this here with x. So this just says minus x squared. This is nearly x squared. It's just I'd want it to be on 4. So this is minus x on 2. No, 2. It's twice it, isn't it? And this is plus 1. Right? This is 2 x's because actually it's minus 2x squared, isn't it? Yeah. Because I can, if I decide to make that instead of out over 2, if I decide to make it over 4, then basically I need to times by 2 because it's supposed to be over 2. And then that is like it's over 2, but the whole thing is being squared. That's where I get my 2x squared from. So that's just minus that minus 2 of, actually, will that be minus that? If you square that, that's just x being squared. I'm going to put a minus there. Minus that is x. That's x being squared. All right. Now, x squared minus 2x squared is minus x squared plus 1. So I'm saying that minus x squared plus 1 should be the equation of the parabola that describes how the vertex moves around. Sorry, I didn't have enough. There we go. Minus x squared plus 1 should describe the value, the vertex, as p varies. So I'm going to put that back on the screen now so you can see if that's true or not. If it's minus x squared plus 1. So I just need to turn this back on again and move over to where you can see the screen here. It should be here. And we'll just log back in and we'll project up the picture from Desmos and see whether it really is. So this should be 6679. Okay. Okay, so you can see on the screen that picture, I hope, uh, of the parabola. So I just got to check what you can see there. If I go to this, yeah, okay. So you can see on the screen that picture of the parabola at that angle. And if I move this slider for P, then you should see this parabola move around. So I'll move this slider for P, and the parabola is moving around, and its vertex is moving as a parabola as well. Its vertex comes up and goes down. Now we reckon that should have been the equation minus x squared plus 1. So I'll just type that in here. Y equals minus of x squared plus 1. And you can see the parabola that it's put up there. And as I move P, the vertex of the parabola is moving along that there. And you can see right in the middle there, it's at 2. And it's an even function now when P is 2. And the vertex moves along here as P varies. And you can see the only time when there's no real solutions to the parabola equaling 0 is where it doesn't cut through the x-axis. So there, but as soon as you get to here, it's going under the axis and it's got 2 solutions or 1 solution there. So you can see it says P equals 4, if you can see that. That's where P equals 4, P equals 2, P equals 0. But when P is any other values bigger than that or less than that, it's under the axis.